So this is part B of the 2008 Form B problem number 5, and we have a graph of the derivative of g provided, and we have some information about g mentioned here, and we're looking for the absolute maximum value of g on the interval from -3 to 7. So anytime we're dealing with a situation where we want an absolute max or an absolute min, as we are right now, and we know that our function's continuous, and we're looking at a closed interval, what we typically do is we like to get all our candidates in place right away. So candidates would be endpoints of your interval, and we have a left endpoint and a right endpoint. -3 and 7 are included in this interval, so maybe the absolute max happens at one of them. And then also critical numbers. So critical numbers would be your stationary points and your singular points, so the places where your derivative is 0 and the places where your derivative is undefined. Now we're looking at a graph of g prime right now, so we kind of have to realize that this is a little bit easier for us to do than it normally is. All we need to do to figure out where g prime is 0 is look at the graph and realize that it's 0 at -1, and it's 0 again at 2, and it's 0 once more at 6. So we have quite a few locations to consider here. We have to consider the x value of -1. That makes the derivative of g 0. The x value of 2 makes the derivative of g 0. And the x value of 6 makes the derivative of g 0. So we have quite a few places where the absolute max can potentially occur. To figure out which one actually gives the absolute max, what we're going to do is we're going to figure out what our function value is at each of these locations. So I want to know what g of 3 is. Excuse me, g of -3. I want to know what g of 7 is. I want to know what g of -1 is, g of 2, and g of 6. So if we know that our absolute max has to happen at one of these x's, if we can figure out what the function value is at each of these x's, we're going to be able to answer pretty simply and pretty easily. So I'm going to start with g of 2. They tell us that. G of 2 is 5, so we know the answer to this one. I'm going to go to g of 6 next, and here's why. G of 6, if we think about what happens with the function value, as we let x range from 2 up to 6, because g prime is negative on that entire interval, the function value has to be smaller at 6 than it is at 5. So that alone is really enough to say that this is not going to be our absolute max. It's not going to happen at 6. But we're going to need to know what the function value is at 7, so if we figure out what the function value is at 6, we can use this as kind of a starting point for that. So if I know that g of 2 is equal to 5, and I'm trying to figure out how much the function value has decreased, since the function is always decreasing as we go from 2 to 6, given the fact that the derivative is negative on that entire interval, think of this as a velocity graph. It's a derivative. The derivative that we've applied most frequently would be the first derivative of position, which is velocity. If the function value at 2 is 5, that's analogous with saying that the position of the object at t equals 2 is 5. How much has the position of the object changed over the course of this 1, 2, 3, 4 second stretch? Now the object is moving backwards given the negative velocity, or the function value is decreasing given the negative value of the derivative. How much has it decreased? How much has the object gone backwards? Well, that's going to be whatever the area of this triangle is. So if we're trying to say what the area of this triangle is, this would serve as an altitude of it. Using 1/2 base times height, the height would be -2 or 2, and the base would be 4 units across. So the area of this triangle right here is 1/2 2 times 4, or 4. Now because the function is decreasing as we go from this x value to this x value, or because the object is going backwards as we go from this t value to this t value, the distance that it's gone down, or the distance that it's gone backwards, is 4 units, or 4 values of y. So at 6, we can say that the function value at 2 plus how much the function value has changed in between 2 and 6 is going to give the function value at 6. And the function has changed by 4 units in the backward direction or the downward direction. So g of 6 is going to be equal to 1. If we now try to find g of 7, if we know that g of 6 is 1, or the position of the object at t equals 6 is 1, and we want to add on how much the position has changed from 6 to 7, that's going to correspond to the area of this triangle. Now this triangle has a base of 1 unit and a height of 1 unit, so the area of this triangle is going to be 1/2 base times height. Now the object is moving in the positive direction given this positive velocity, or the function is increasing given this positive value for the derivative. How much has it increased? Well, it's increased by a 1/2 unit over the course of the time frame from t equals 6 to t equals 7. How much has the position changed, or how much has the value of the function changed? Well, it's changed by a 1/2 unit, and it's going upward given the increasing nature of the function from 6 to 7. We're going to have 1 plus 1/2, or 3/2, as the function value at 7. So this is not our absolute maximum either. So 2 is still our max as of the current time. We do have to figure out what the function value is at -1 and -3 though. This is going to be a little bit trickier. The reason why is because what we're going to have to do is we're going to have to kind of go in reverse. We know the function's position at 2. At t equals 2, the function value is 5, or the position of the object is 5 units. The object moved in the positive direction from -1 to 2, or the function increased from -1 to 2, given the positive value of the derivative between those points. How much has the function value actually increased? Well, the function value has increased by whatever the area of this triangle right here is. So if you try to specify the dimensions of this triangle, 1/2 base times height, to find its area, this would correspond to the height because that's an altitude to this base. So we could use 1 as the height, and then the base would be 1 unit, 2 units, 3 units. So the area of this triangle right here would be 3/2 square units. So from the t value of -1 to the t value of 2, the position of the object has gone up given the positive velocity, or the function value has gone up given the positive derivative, hence increasing function, by this much. So if this is the function value at 2, and this is how much it's gone up by on the interval from -1 to 2, all we need to do to find out the position or the function value at -1 is take what we know the function value to be at 2 and then subtract off how much we just determined it increased from this x to this x. So that's going to end up being, let's see, 10/2 minus 3/2. It's going to end up being 7/2. So this is still, as of right now, our absolute max. The only value that it could bump it out would be at -3. So here's what we know. At -1, the function value is 7/2. What happened with the function value as we went from the x value of -3 to the x value of -1? The derivative is negative on that entire interval. That means that the function value must have decreased as x ranged from -3 to -1. How much did the function value decrease? How much did the position of the object decrease as t ranged from -3 to -1? Well, it's decreased by whatever the area of this triangle right here is. So if we use the base of this triangle being 2 units and the height of this triangle being 4 units, the area of this triangle would be 1/2 times the base times the height. So that's going to be 4 square units for the area of this triangle. That's how much the function value has decreased. Negative derivative on that interval. Function value has to decrease as we go from -3 to -1. The function value is decreased by 4 units as we go from this x to this x. if we know that at this x, the function value is 7 halves, and that it decreased by 4 units as we went from this x to -1, we're going to have to add on how much the function value has decreased over the course of this range of x values, -3 to -1, in order to figure out what the function value had started at -3. So this is the first time that we're doing this. This is going to get easier for us to do the more and more we do it, the more that we relate it to velocity, the more comfortable we get integrating rates of change or integrating derivatives. So it's a little bit tough this first time, but it should get easier and easier the more that we see it as something that we want to try to do. If we're trying to develop an answer here, let's see, this would be 7 halves plus 8 halves, which would give us 15 halves, and 15 halves is definitely above 5, so our absolute maximum happens at the x value of -3, and it happens to be 15 halves.